So I can take this thing out, you know, and put it in all day long, and it's gonna read like 106, 107, depending on the thing, depending on where I get in there.
Okay.
So
So that is,
this is probably where it was.
it's reading 108, 106.
Yeah, when I slid it in, this sample does vary a little bit.
Okay.
So I'd have to actually put a thin gauge block in there, because this piece of semiconductor is probably not 100% flat.
Do you want
Now if you watch, so we calibrated to this. Now as I slide the copper foil in here, oh, okay, now we're reading 10. So we got lucky, but as I move it around, you're gonna see it change. And these are the dents that are causing that.
So it looks like some are 5 or 6, and
Yeah, it's up and down because of the flatness of the thing. It's just funny that I happen to get it almost what it is. See, so the variation of the material in there, the up and down warps the field, and that causes it to be off a little bit. The only way you can read this exactly right is if this copper was absolutely flat. So one of the things we want to do is to set up that thing over there and read the step height of copper going through that.
okay.
And then what that would do is actually smooth out the sample because you got tension on it. So this thing here, if I try to stretch it out, it'll probably get closer to 6 as I smooth it out, but it's tough to do that, you know. So if they're going to read this stuff in process, it's got to be absolutely flat. Now, perhaps as it comes out of the production, it's flatter than this. But once you handle it, you get those wrinkles in there. There's no way you're going to get them out again.
Right.